about the sleepworks analyzers, and the way I decided to approach this was to first introduce you to what analyzers are available. I'll provide you with a general overview of each of the analyzers and give you an understanding in terms of how they work. Now, the analyzers in general are proprietary, and so I'm not at liberty to disclose every factor and variable that they're looking at, but I will do my best to disclose and educate you as much as possible on the types of information that they're looking at. I do have to make this disclaimer up front just for the record, and that is the clinical relevance of events of interest. In other words, the events identified by the analyzer is determined by the professional judgment of a medical practitioner trained in sleep analysis. No clinical or diagnostic claims are made. The output of the algorithm or the analyzers should always be reviewed by qualified personnel. All right, so in no way should these analyzers replace the opinion and review of a medical professional. They're simply designed to provide some assistance. To see the analyzers that are available, you can access them by going into your database window and by going to Tools, Options, and if you click on the Analysis tab, you can see where the analyzers are located. There's your Analysis tab. Now, if you go to the Add button here, this will display all of the analyzers that are currently available. So if you look at the first one here, all I do is just explode that picture there. But here's a listing of all the analyzers. You will see a mixture of sleep and EEG analyzers, especially if you have the license for them. So in this particular view here, we see AEEG, CSA. These are all EEG analyzers, the QEEG and the XL event, intracranial and XL spike. So just for clarity, I decided to just remove the EEG ones, and these are sorted alphabetically. And for further clarity, I just kind of group them into various categories. Staging, arousal, these are our respiratory analyzers. All right, we've got a separate snoring, we have an oxygen, one for limb movements. Notice that it says limb movement, it doesn't say leg movements. In the event that someone wanted to use electrodes on a patient's arms, for example, this could be used to detect movements in the arms also. Gradient tachycardia, breath rate, heart rate, and the data trends. All right, so what I'd like to do first is to just talk to you or just describe to you how these analyzers can be initiated. So for this, I'm going to share my desktop. Okay, so I've got a recording started here. Well, I'm not actually recording, but I am in acquisition mode. Now, analyzers can be initiated during live acquisition during a recording. In other words, you can have the analyzers detect events in real time, or just a few seconds after real time, so to speak. I'm going to start recording. I'm going to put a lights off tag. Right now, the auto staging is not working. Okay, so if I left click on it, in other words, I place a check mark beside it, it will start to analyze. Now, you'll notice that this list is only displaying a short list of the analyzers that are available. And the reason why is if we go to Edit Settings and we look at our window, the Analysis tab, here we have a list of our analyzers. So the list that I just showed you in the acquisition window under Analysis will only display the analyzers that are displayed in this window. Okay, so this is part of the process of enabling analyzers to run during a live acquisition. So I'm just going to click on the Add button, and I'm going to add the rest of the other ones. I'm going to add central apnea, central hypopnea, data trends, heart rate, hypopnea, limb movement, obstructive apnea, obstructive hypopnea, oxygen desaturation, and snoring and tachycardia. Okay, so I've added these. There's also there's a column here where you can specify the study type. All right, so these are all for sleep. There's an activation column here as well. You can have these analyzers activate by themselves after a lights off tag, or you can also say just have them activate always. And always basically means the moment you start recording the study, activate the analyzer. If you wanted to change the activation method, you can just click on the button here and just pick never or always, and some of these will have an additional option that says lights off. If you see schedule is actually used originally in the EEG world, where they would actually schedule the analyzers to run during a particular time. I would say a number of years ago, where processing power in the computer was more of an issue, it was difficult or challenging to have the analyzers run during an acquisition because it would use up a lot of the computer's power. And so the idea behind this was to run the analyzers during off-peak hours. But this is something that I really haven't seen used by, I don't think I haven't seen any lab, frankly, using these analyzers on a schedule. But you can set a time limit or a time to start analyzing. So the defaults are usually after lights off or the always option. All right, so you've seen that I just added these options to the analyzer list here, and I'm going to click OK. Now, if we go up here where it says Analysis, you'll notice now that this list has been populated, and that's because we added them to that analyzer list under Edit Settings. Because we set the activation to always or after lights off, this is why they're all checked right now, because we are recording, we inserted a lights off tag, and so the analyzers are basically running because that's the activation that we set for them. At any point in time, you can see at the bottom here, you can see the auto-staging analyzer is currently running. It's starting to plot the hypnogram at the bottom. At any point in time, if you want to turn off any one of the analyzers, you can go up to it where it says Analysis, and you can simply just uncheck. All right? You can just uncheck and say, you know what, I want it to stop running. And I'm just left-clicking. So when you're left-clicking, you're removing the check mark. If you left-click again, you're adding the check mark. So you can control the analyzers from here as well. So this is an example of where we are running the analyzers during acquisition. Another option is to run the analyzers after the fact. So you saw how populating this window with analyzers also populated the options available in this menu. Well, similarly, I'm just going to go back here and just remove a bunch of these for demonstration. All right, so I've got a partial list there. If we go back to the database window, let's say we have a study and we want to run the analyzer or submit it for analysis, we would select our study and we'd click the Analyze button. So you'll notice that the list here, this reflects what we had just displayed in the analyzer window. So if you're ever trying to submit a study for analysis after the fact, and you're looking at this window and you're saying, what happened to all my analyzers? Where are they? That's a sign that you need to go back. Either you can go back and do it through here, or you can also access the same menu by going to Tools, Options, Analysis, and you could simply just re-add the analyzers back through here. Movement, structure, yeah. Okay, so now when you click Analyze, our window is now populated to reflect the list that's in the Edit Settings window. All right, and then you can manually select which analyzers you want to submit for analysis, and when you're happy with your selection, you can click on the Submit button, which I'm not going to do right now because I'm running the study, but you can click on the Submit button, and then the analyzer will begin to run. All right, I'm just going to switch to a study that I have opened in review, and this is a study that I already submitted for analysis, and it contains a list of events that were analyzed or annotated by the analyzer. So first off, we have the arousal analyzers, And the arousal analyzer is basically designed to detect any arousal, in other words, any change in frequency that is greater than 3 seconds but not greater than 15 seconds. And it's designed to look at any channel that is designated as an EEG type. So in your montage, any channel that is designated as EEG, all right, will be looked at. And there's one down here as well. So it's not restricted or limited to just your, just a certain channels. It applies to all channels that have type, the channel type, set to EEG. You can tell it's an event marked by the analyzer because you see a little A in the bottom left-hand corner. All right, so you can see that over here. If you double-click on the actual event tag, it'll list the arousal. It'll tell you the channel that it was marked on. Now you'll also see, depending on the version of software you have, you might see some additional information here. These are all relating to attributes of that particular event. Now, these were added, again, it depends on the version of software that you have. These were added because when the analyzers were getting tested and validated, the programmers that were looking to uncover some of the individual values that were used in the detection of the arousal itself. And so I do not get too hung up on what these individual values mean. Some of them relate to actual voltage values. Some of them relate to percentage values. Some of them, like duration here, is pretty straightforward. That designates the duration in terms of seconds. Probably the most meaningful one, though, is, again, the name of the arousal, the name of the event, and also the channel that it's labeled on. You'll also see at the bottom here where it says created. It'll specify that it was created by a sleep event. In other words, this denotes that it was created by the analyzer. Again, depending on the version of software, you might not see sleep event. You might actually see something that says created by analyzer or created by batch analyzer. If you're logging into your individual system, so I'm just going to manually mark a tag right now. I'm going to manually mark an arousal. Or this is a rare. Let me just change that to an arousal. Okay, so you can see the difference. This one has the A in the bottom left corner. This one does not. If I double-click on this one, it says that this was created by Afavolio, and that's my login name. So you can tell who laid the tag, whether it was done by the analyzer or whether it was done by a user that is logged into the system. So if you're not using your logins, this is one reason why it's probably a good idea, just to kind of keep track of who is actually laying the tags. Now, arousal detections, the rules for arousal detections, can be found under analysis, and if you click on the arousal option there, it'll display some attributes there at the bottom. The arousal to background contrast, basically, we've tried to, or the programmers have tried to simplify the settings. They're not going to display all of their parameters that they're using, but they tried to simplify this to a degree. And so the default settings, these are the settings that were found to be optimal in terms of real-life detections. And so this is why we've called them the defaults. But again, we're not making any claims on this, but we found that the defaults tended to have a greater success rate. If you want to change it, you can click on the drop-down and you can just try. So if you change this to medium or to high, that'll result in fewer detections. So you can experiment with this. And what I tell people when it comes to the analyzers is you need to be prepared to take some time and just run the analyzer a couple of times and changing the settings. Ultimately, it's about looking at the final results and comparing the final results and seeing which one offers you the greater success rate. The minimum time between arousals, this is pretty straightforward. It's just the time gap between arousals. You can specify a parameter there between 2 and 20 seconds. Now, not all of the analyzers have parameters that can be configured. So for the next one, we're going to talk about auto-staging. Auto-staging, you can see here that it does not have any user configurable settings. But I just want to make a few comments about the auto-staging analyzer. So depending on the version of software that you have, first of all, if you're using any version of software, I believe 6.1 and above, so if you're using 6.1 or 6.3, you'll notice in the top corner, left-hand corner of your epic, that the epic number and the stage color is in red font. And as I advance forward, you'll continue to see the same color for different stages. Color does not correspond to different stage colors. Rather, if you see red, that denotes that this was an epic that was detected by the analyzer. If I were on epic 310 right now, if I were to click on or press the 2 button on my keypad to manually stage this, I'm going to press 2. All right, it advanced to the next epic. Just going to move that. All right, I'm going to go back to epic 310. You'll see how it's changed to gray. So if you manually mark it, the epic number and the stage will appear in gray. If it's marked by the analyzer, it will appear in red. Now, those of you that have version 7.0, where the staging and the epic number are now shown as a watermark in the background, the colors in 7.0 actually do correspond to different stages. So the way it's denoted in version 7 is if the actual stage of the watermark is italicized. So if you see it slanted to the right, italicized, then you know that it's been staged by the analyzer. If it's not italicized, then it denotes that it was manually staged by a user. So these are two differences between 7.0 and 6.1. Now, just a few comments about the auto-staging analyzer. The auto-staging analyzer, they're all programmed to look specifically for specific channels and sometimes specific channel types. That's why the montage becomes very important, and I'm going to elaborate on this a little bit later. So, with the auto-staging analyzer, it was designed to look at channel C3, C4, A2, A1, O2, O1, and the chin channel, as well as the left eye and the right eye. Basically, anything that was marked as stage 3 and 4 under the R&K rules, if you switch to using the new ASM guidelines, your N1, N2, N3, and REM stages, the analyzer will simply relabel stage 4 as N3. Okay? Now, in order to have the auto-staging analyzer work well, it was designed to begin working at the very beginning of a recording. All right? And the reason is that it expects that at the very beginning of your recording, or shortly after lights off, it expects that the patient will be awake. And based on that, it's computing a baseline from which to base other frequencies and staging characteristics for the other stages. So to achieve the best results for the auto-staging analyzer, it's best to have your analyzer set to always. I mean, lights off will work too, just as long as when you click on lights off, that lights off occurs while the patient is still in awake stage. And again, that's because the analyzer is expecting to compute some baselines when the patient is awake, and they're expecting this to occur at the very beginning of a nap. Here's a sample study. It's the same study. All right, so what I did was, so I took this study here, and these are the results, the hypnogram that was computed by the analyzer. Later, I just took a clip of the study, so I just clipped it from this point, all right, from here to about here, and I created a prune study. All right, the exact same study. The only difference is then, when I ran the analyzer for the whole study, these were my results. When I created a prune study, in other words, I never had, this gray portion here. I only had this clip right here, and I ran the analyzer. You'll notice that there is a slight difference in terms of how the auto-staging analyzer works, and the difference appears to be mostly with the detection of REM. You don't see the REM sleep down here. So my point is, it's the same study, but because we don't have the first part of the recording, or at least the part of the recording where we expected the patient to be awake, it's actually affected the outcome of the staging hypnogram. It's ideal that you start your auto-staging at the very beginning or after lights off, but ensuring that the patient is still awake when a lights off occurs. All right, so with our respiratory analyzers, we're basically looking at one screen. So I'm going to edit, settings, analysis, and I'm going to click on central apnea, for example. So when you click on central apnea, you'll see the settings here. So let's just look at some of the settings here. So the reduction in respiratory amplitude for hypopnea. Now, even though it says we're clicking for central apnea, it's still asking us to designate what's the percentage drop in amplitude. So the amplitude for a flow or effort channel, we're expecting a 30% drop. For an apnea event, we're expecting a drop of at least 80%. And then the minimum respiratory event duration, here we're specifying 10 seconds. So regardless of the respiratory analyzer, if I click on central hypopnea, it's the same screen. Okay, so if we go down here, obstructive apnea, it's the same screen. Obstructive hypopnea, it's the same screen. Because it's basically applying the same rule to all of the respiratory events. When we're talking about these amplitudes, some people have asked, when you're looking at the analyzer, it's not a moving window. So as the software is going through and it's attempting to compute an average baseline, okay, it's not going to just look at the previous 10 seconds or 20 seconds. It's not that simple. If you imagine someone who's experiencing respiratory events, someone could be experiencing an apnea for 10 seconds, and then they take a few breaths for, a few seconds, let's say another 2 or 3 seconds of normal breathing, and then they go back into another apnea. If we were to look at if we were to try to average a new average amplitude, we would be including 3 seconds of normal breathing along with 10 seconds prior of apneic breathing, and that wouldn't necessarily give us an ideal average amplitude. And so it's not a moving window. The algorithm is a little more complicated than that, and it does go back a little further. Now, for the purposes of just demonstrating these reduction values that we're talking about, I put together this little diagram here. So the software is basically, it's attempting to compute a breathing pattern, a normal breathing pattern, or a baseline, and it will designate this as 100%. So here we call this normal baseline breathing. You'll saw that in the parameter there where it says analysis, we said reduction from the amplitude of a normal breath, 30% for a hypopnea. So basically, if the amplitude drops 30% of the 100%, all right, but not greater than 80%, because that's where we set our apnea, then it will be considered a hypopnea. All right, as long as, of course, there's the other parameter here that the duration also has to be 10 seconds. For apnea, if there's an 80% drop, then it will be considered an event for apnea. All right, so essentially, if it's between 30 and 80%, we're looking at a hypopnea. If it's greater than 80%, we're looking at calling the event an apnea. And of course, in each case, there has to be a minimum duration of 10 seconds. So back to this window. All right, there's our 30%, there's our 80%. All right, so 30% and there's our 80%, and that's what those values correspond to. Now, I know that the ASM will define hypopnea a little bit differently. It's not just based on amplitude. And so to answer a question, does the hypopnea analyzer look at associated desaturations or whether or not there's desaturation and an arousal? No, it does not. This is strictly based on the amplitude of the flow channel and the amplitude of an effort channel. So when the software is going through your record, it's looking in your montage for any channel, such as it's looking for either a thermistor channel. I'm going to right-click on this. It's looking for a thermistor channel, a flow type channel, or a CPAP flow channel. All right? And it's also going to look at any one of your effort type channels. So based on the amplitude of either one of a thermistor, flow, or CPAP and one of the efforts, based on the amplitude of both of these channels, it's going to determine whether the event is obstructive or central. Now, there is a generic event called apnea and hypopnea. All right, so we do have a generic event here called apnea. Now, the apnea, if the montage in the study is missing a flow or an effort type channel, all right, so if it's just missing any one of those channels that are required to determine whether or not it meets the obstructive criteria or the central criteria, then, but it does detect a reduction nonetheless in amplitude in the one channel that is present, then it will use the term apnea. So similarly with hypopnea, if you don't have a flow and one effort type channel in your montage, but it does detect an amplitude reduction in one of the channels, it will present with just a generic hypopnea tag. All right, so let's talk about snoring. The snoring analyzer, basically, the parameters are pretty much, if you hover your mouse pointer over the text box there, there's a little tooltip that pops up, and it's providing you just with additional information. But essentially, it describes what the snoring analyzer is looking for. So it's looking for a minimum duration. It's looking for max duration. If you've got multiple snores, do you want to combine them? So the snoring analyzer will specifically look in your montage for any channel where the channel type is specified as snore. Okay, so it's important that the montage has the proper channel type selected, because this is what the analyzer is going to look at when it's detecting or looking for potential events. Now, with respect to the snoring parameters, again, there are some parameters here that you can adjust. If you can increase the sensitivity, you can decrease the sensitivity of these values, resulting in more or less detections. And again, this is something that you should really, if you're really interested in fine-tuning it, I would advise just to take a study or two, or even just take one study, and just experiment, primarily with these two values here is where I've seen the greatest difference. You can experiment with the values. If, for example, if you lower the minimum snore amplitude here, you'll find that you are decreasing the sensitivity and resulting in fewer detections. Alternately, if you lower this score, this will generally result in a greater number of detections. And so you can play with these values if you like. Again, these default values are there for a reason, because this is where we've found the most success. The snoring analyzer is very similar, if not identical, to the limb movement analyzer. All right, so if you look at these values here and you click on limb movement, you're essentially seeing the same parameters there. Same parameters, but different values. And again, if you find that lowering this value, you may result in fewer detections. Lowering this value may result in increased detections. And so, essentially, if you look at the limb and snore movement channels, they're similar in many ways in terms of we have a background amplitude or baseline frequency, and then we're looking for changes in frequency corresponding to a leg movement or to a snore. All right, let's move on to the desaturation analyzer. This is probably one where I get the most questions from. The desaturation analyzer, let's go into edit settings and talk about this for a minute. So let's look at our desaturation analyzer. The auto baseline is basically an algorithm or analyzer that looks at a number of variables. When it comes to these analyzers, again, I would say the best thing to do is to try them and put together a comparison of which one you feel best suits your results. Auto baseline is an option. There's another option that says average amplitude over duration. All right, I'll come back and talk about these in a second. And there's also another one here called absolute baseline. And the absolute baseline came about because there were a few labs that actually requested specific value, 90%, 85%, whatever, and they considered anything that dropped below that value to be a desaturation. And so that's where the third one came about. So what I would recommend, again, is take a study and run all three of them, all three types, on the same study and compare your values. I did that on one sample study, and you can see here. So the auto baseline, so here, it's the same study, okay? It's the same study, and this is when I ran auto baseline. All right, this is when we ran absolute baseline. We set it to 88%. This is where we set average amplitude with recovery from the valley. I'll come back and explain these in a second. There's average amplitude with recovery from the hill. Now, if you look at these samples here, and if I were to ask you which one do you think best captures how you would do this in the lab, when I've asked that question to other lab people, generally speaking, the most popular one is the auto baseline. Now, I don't think that the auto baseline is actually the default. I'm not sure if I don't think it's the default that is set with the software. It may or may not. I'm not 100% sure. But the auto baseline, I mean, if you look at it, I know the comments that I've received from people is that this one clearly, if you look at this one here, you see a drop, it recovers. We call this one event. You see another drop, it recovers, it's one event. You see another drop, it becomes one event. And so this one here, we've got 1, 2, 3, 4, 5 events. Now, if we look at the next one here, the absolute baseline, you start to see things like this. If you look at this one here, there's just a short duration here. And it's difficult to see the drop in this one here, and people start asking, why is this considered a desat? Same thing with this one here. Moving down the line, if you look at this one here where it says average amplitude, again, you're seeing an incline here, and people start asking, why is this considered a desat? And if you recall earlier when I said with the respiratory analyzers, I talked about how the system will compute an average amplitude. And the amplitude, again, it's not a moving window. So it's not as simple as, let's just look at the previous 10 seconds or 20 seconds of data. The analyzer is a little more complicated than that because it's trying to account for drops, for old baselines, new baselines. And so just because it says average amplitude, it doesn't mean that it's looking only at the previous 10 seconds or 20 seconds. So when you see something like this one here, this short one here, I mean, you don't even see the drop, and it's the same thing here. You really don't see a drop there. Though you don't see a drop in the previous 10 or 20 seconds, but it may still be comparing that particular signal with an amplitude that was computed using data perhaps a few minutes ago. All right, but that's not readily intuitive by looking at it on screen. And these are one of the analyzers aren't 100% perfect by any means, and this is why we've got varying success rates with the analyzers. In general, the success rates of all the analyzers vary, I believe, from 60 to 80, I think as high as 88%. So it depends. And so when you see something like this, it's, like I said, it's comparing it to an amplitude value that was computed using data from several minutes back. And so that's why you start to see stuff like this. But then again, this is why the analyzers require, the review by a qualified person to go back and to kind of clean up and delete some of these events. Ultimately, the decision lies with you. Is it easier? Would you rather have the analyzer detect a bunch of events and then you go back and delete them? Is it easier to delete the false detections, or do you just prefer to draw them from scratch? If you look at the diagram here, again, you can probably see why most people tend to prefer the auto baseline, because here you can more clearly see the drops, and each drop is associated with one event. Now, when you're using the desaturation analyzer, it will also provide you with what the actual percentage drop here. So if you look at this one here, it says a 9.7% drop, a 13.8% drop. If I were to manually draw an event, you will not see what the drop is. I'm just going to click and drag, all right? And you'll notice that when you manually draw an event, at the present time in this version of software, it does not display what the actual DSAT is, but the analyzer will display that. And so I know a number of people use the desaturation analyzers because they want to see what the actual percentage drop is. I'm going to double click on this. Again, created by the batch analyzer, and it displays what the actual drop is. You double click on a manual one, and it simply tells you the channel that you've laid it on. It does not specify what the actual drop is. All right, I'm just going to delete this one. Let's go into the rules for these analyzers, or sorry, for the desaturation. So the desaturation, this one here, and let's start off with auto baseline. So the auto baseline, again, this is really one that's just automatically computing its own baseline, and it appears to be one that is pretty popular among the labs that I've seen. Now, with the auto baseline, you can decide, you have some options here in terms of where you want to decide, where you think the end of the desaturation should end. So there are a couple of options here. There's a recovery from the valley, and there's a recovery from the hill option. And here you can specify the percent. So I want to demonstrate this one by showing you this slide here. All right, so here's a sample oximetry signal. All right, so at point A, we've got 93%. So if our determination was specified that we're going to end the desaturation event when the OSAT value recovers from the valley 3%, then we'll end it at point C. All right, so let's look at the signal here. We're at 93. It drops. So the lowest point, which we call the valley, which is point B, is 74%. So it drops from 93 to 74. Now it starts to climb back up. When it reaches point C, it's at 77%. So in other words, it's recovered from the valley a total of 3%. All right, up by 3%. So in this case, we would mark our desaturation event right there. Okay? So that would be our event. If we decided to use the recovery from the hill option, let's continue to follow this line. We're dropping to 74%. We've moved up 77%, and we're dropping again, and we're slowly climbing. Well, the hill would represent point A. So by saying it has to recover within 3% of point A, well, we take our 93, we subtract 3%, that brings us to point 90. So essentially we're saying when the signal climbs back up to within 3% of the hill, which is point A, that's where we'll end the event. So in this example here, point D is where the oximeter value reaches 90%, which is within 3% of the hill. And so if we were to mark our event, we would actually mark the DSAT like so. All right? So this is the difference between recovery from valley and recovery from hill. So recovery from valley would take it from here to point C, and recovery from hill would take it from point A to D. And you can specify that using those parameters there. There is another parameter just below the termination rule. So if I go back, there's another option here that says enable steady state termination. All right, so if I check this, all right, now it also enables two other parameters. And what this is designed to deal with are situations where you've got a drop. All right, here's our hill. Our oximetry drops. All right, we reach the valley, and it doesn't really recover. All right, it's almost like it's forming a new baseline. All right, so it was, if we look up here, it looked like it was around 94%, 94.5%. And it drops to about 89.5%. All right, and it really doesn't recover. So 30 seconds. So from the valley, 30 seconds have now gone by. Another 30 seconds. We're at 60 seconds. So from the point of the actual drop, we're looking at 90 seconds. Well, the question becomes, if we're going to draw a desaturation event, are we going to draw an event that is yay long? And would you draw a 3-minute, a 4-minute, a 5-minute desaturation event? I don't know. That depends on the lab and what your protocols are. So with this particular rule, the enable steady state termination, what this does, it's designed to address how long you allow this event tag to continue. So here we're saying if the OSAT signal does not change in either direction by more than 1%, which is this value here, okay? So here's our signal. Let me just delete the red mark here. All right, so our signal drops. It continues more or less hovering about the 89-90%. If it continues and it doesn't change up or down by at least 1% for at least 60 seconds, then you can terminate the event after 60 seconds, after that steady state. So from here to here represents 60 seconds. You have 60 seconds of a signal that's not really moving in either direction, then terminate the event after 60 seconds. All right, so from here to here, 60 seconds. It's not changing up or down by greater than 1%. Terminate the event right here. So if I had to draw the desat, it would look like this. Okay, so we've talked about these ones here. Now I want to talk about the bradycardia, the tachycardia, breath rate, heart rate, and data trends. So I'm kind of grouping these together for a reason. First of all, brady and tachycardia are based on, it's basically looking at your pulse rate, your heart rate. And in order for it to look at the pulse rate or the heart rate, your heart rate analyzer needs to be enabled. Now, the heart rate analyzer is not something that's going to lay a tag on screen. All right, you will not see that. What you'll see is on the EKG channel, you'll actually see digital values displayed on screen. Okay, so if you go, just going to click on heart rate. Okay, there are no settings for this. Just going to right-click, go to channel properties, display the heart rate values. All right. Now, you'll notice here, I just clicked on display heart rate values. It didn't show anything. And that's because the heart rate analyzer, you cannot run this after the fact. So it's different from the other analyzers. If you didn't run the desaturation analyzer, the arousal, any of the event tag ones, if you didn't run it during acquisition, you can always submit them for analysis after the fact. You cannot do that with the heart rate analyzer, and you can't do it for the breath rate analyzer. These are real-time analyzers which need to be enabled. And so what I advise people to do, is by default to ensure that your system has breath rate enabled, that it's always on. Ensure that your heart rate is always on. Because even if you don't want to see the values, at least you have the option to go in here in the channel properties, and you can choose not to display them. Okay? There's another analyzer. Sorry, one more comment about the breath rate and the heart rate. So the heart rate analyzer needs to be turned on. If the heart rate analyzer is on, you'll see, and you've got digital, you're displaying your digital values, then that will allow the brady and tachycardia analyzers to work also. The brady and tachycardia analyzers are basically based on the heart rate values that are detected. And it's just basically looking at the values and whether if you are within the threshold, it'll classify and lay a bradycardia tag or a tachycardia tag. Okay. So the last one I want to talk about is the data trend. The data trends analyzer is responsible for displaying your OSAT trends. It's responsible for displaying a trend based on your flow signal. All right, I'm just zooming in here. All right, so if you want to trend your flow signal for the entire night, data trends needs to be enabled. Data trends will also trend the chest channel. It'll trend the flow channel. This study doesn't have it, but it will trend a CO2 monitor. It'll trend that as well, and the oximetry. So data trends is responsible for trending channels in the trend window. Now, not all channels are available for trending, with the exception of the respiratory channels are designed, and also the DC channels such as CO2, pulse rate, and oximetry. So the data trends analyzer is responsible for drawing these values down at the bottom. So by default, if you're a lab and you're not interested in using any of the analyzers, I would say at the very least, make sure that you're always running breath rate, heart rate, and data trends as a minimum. Because those analyzers, they're not laying event tags on the window. They're responsible for just displaying information. And you can choose not to display the information if you don't want to. All right. I'm going to move on now and talk about configuring analyzers. I'm just looking at the time here, so I'm going to speed this up here a little bit. In order for analyzers to work properly, because I do receive some questions at various times, someone will say, I've enabled the analyzers, but I'm not getting any events. All right, so, and to demonstrate, I want to talk about a couple of things. So first of all, let's talk about the scenario where we want to submit the study for analysis after the fact. It doesn't really matter, but I'm going to talk about that in this particular case. So first of all, it's important that when you're running an analyzer that the analyzer you're interested in is actually showing in the window, because by being displayed in this window, it actually enables it. Okay? And you've got your activations here. Make sure these are set to either always or lights off. If you have a study where you never put the lights off tag and your activation is set to lights off, then you will not get any events. If your activation is set to never, then even though it's displayed in the window and you run the analysis, it's not going to detect anything because you've got your activation set to never. All right, so that's one thing. The other thing that's important is the analyzers. So regardless of the montage that you use to record a study, the analyzer can apply and will apply its own montage over top of what you've recorded. All right? So by default, we include in the software. So if you look up at the top here, and when you install the software, a study, for example, that is recorded using the Connect Brain Monitor, the default setting is to analyze the study using the Connect XL Detect montage. All right? So, let's look at this particular study. This study here was recorded using a HIPPO. Here we go. Let's go back here. It was using a HIPPO amplifier. So, what we're saying is any study that's recorded using a HIPPO should also use the HIPPO XL Detect montage. So, here's our recording montage. All right? But when the analyzer is going to run, it's going to go in here and change the montage to XL Detect, and it's going to detect events based on this montage. So, what you need to make sure is that the HIPPO XL Detect montage contains the channels that were used in the recording. Now, to demonstrate this more clearly, I have a sample study here that I want to use. And I'm going to pull up this one here. Okay, review. All right, so here's the study, and let's look at the montage. All right, this is the montage that was used. In this particular study, this lab, they were using a thermistor. They were also using a PTAF, an airflow pressure transducer, And you'll see that they used the generic DC as the channel type. They use the chest and they use the abdominal effort. So I'm going to look at the example here. Let's say our respiratory analyzers aren't working. Or let's say we want to get the respiratory analyzers to work. So this study was recorded using a Connect brain monitor. This is the montage that was used to record it. If we go to analysis, here we've specified, all right, the default, I'm just changing this back. The default, when you receive the software, install the software, any study recorded with a Connect brain monitor will use the Connect XL Detect montage to detect events. All right? So we recorded with this montage, and I want to draw your attention to these particular channels here because we're going to talk about the respiratory analyzers. All right? So here's our airflow pressure transducer. Now let's switch to the Connect XL Detect montage. All right? What's different here? You don't see the airflow pressure transducer channel as part of this montage. So if the airflow pressure transducer channel is not part of the montage that's going to be used to detect these events, it will not detect the events and mark the events in your study. Okay? So the solution then, you need to check that because sometimes the montage that is used to analyze the study does not contain the channels that were used to actually record the study. So in that case, we need to change it. So if we look at the default staging set here, here's a particular study. We're just going to leave the settings here as analysis. We're going to leave it as, I'm going to change it back to Connect XL Detect. Click OK. Let's close this. OK. You want to save changes? Yes. All right, tools, options. I just want to double check here. Okay, so this is our default. When you're recording, when you're analyzing a study using this head box, apply this montage. Okay, I'm going to submit this study for analysis. And to speed things up, I'm just going to run the auto staging and the respiratory analyzers. Okay. Let's click Submit. All right, let's open. Just cleaning this up. Okay, so we just ran the analyzer on our study, and I'm looking at our graph here. Are there any events? One obstructive hypopnea was detected. All right, let's go to that event. Double-click on it. It detected obstructive hypopnea based on the flow channel. So it looked at this one here. Okay, created by the batch analyzer. Now, you might say that there are more events in this study, and it missed them. And it's like it didn't look at this P-flow. Well, why didn't it look at the P-flow? Well, if you recall, the Connect XL Detect montage is only going to look at flow, abdomen, and chest. Okay? If you wanted to look at P-flow, then we need to change this. Now, we need to change the analysis montage. So, one option is to right-click and change it as recorded. If you change it to as recorded, then the analyzer will look at the individual channel types that are in the montage, and if the channel types are appropriate and the detection column specifies that they are for sleep or EEG or sleep, then it will look at it when it performs the analysis. So if I change this to use the as recorded montage, do you think this will work? Well, we wanted to look at P-flow, but I'm looking at this montage. Whoever set this up at the lab, they set it up as a generic DC type. And I also see that in the detection column, it's also disabled. So even if I tell the analysis, all right, to use the as recorded montage, which is this one here, you still won't get any results because it's disabled and the channel type is set to generic DC. Remember, the analyzers are designed to look at channel types and in some cases channel labels, but mostly channel types. So if the analyzer is going through this particular study using the as recorded montage, it's not going to know that the P-flow, the airflow pressure transducer, was used with a channel type that's called generic DC. It's not going to know to look for that. So what we need to do is create a different montage for the analyzer to use. So what I'm going to do here, I'm just going to create a new duplicate. And I'm going to give this a name, and I'm going to call it Analyzer Montage. I'm going to click Apply. And now I'm going to create a new analyzer montage. And now I'm going to create a new montage that I want the analyzer to use to analyze the study. This time, however, I want the analyzer to look at the P-flow channel and use that channel to detect respiratory events. So in this new montage, I'm just going to shorten this montage and I'm just going to eliminate all these channels. I'm just concerned about the respiratory analyzers right now, just for the purposes of our demonstration. Alright, now this time we're going to change our P-flow DC channel. From generic DC, we're going to change it to, and call it a thermistor, because I know that if you name a channel thermistor, I know that the respiratory analyzers are on the lookout for any channel in a montage whose channel type is set to thermistor. So I've got that set, and I'm going to go over to my detection column, and I'm going to right-click and enable it for a sleep study. Alright, so we've got our effort channels, they're all set up for sleep, so we're good to go. So now I'm going to click Save Common, save this analyzer montage. Alright, and now that I've saved my montage, I'm going to need to refresh this menu, so I'm going to click OK. I'm going to go back in, go to the Analysis tab, and I'm going to change the montage that's going to be used to analyze this study recorded with the Connect Brain Monitor amplifier. From the As Recorded montage, I'm going to ask it to use my new analyzer montage that I just created. I'm going to click OK, and I'm going to exit the program and go back to my window and submit it for analysis. I'm going to click Submit. Let's open our study. I'm just going to load our analyzer montage, look at it with our analyzer montage, and I'm just going to change the sensitivity, and you can see the study now has a greater number of detections, and we can also see that in our hypnogram at the bottom here. We can see our plots displaying a number of hypopneas and apneas that were detected by the analyzer. So this example, I think, clearly demonstrates that even if you use a different channel type, a channel type that the analyzer is not designed to use, you can recreate a montage, add the same channel that you used for the recording, but in the montage change the channel type to reflect one of the channel types that you know the analyzers will look at. I'm just going to pull up another study where I ran this. It might be unique to that study. Okay, here's another study that I did. It was recorded with an EMU 40 head box. If you look at the montage that is used to analyze events with an EMU 40 head box, it is an EMU 40 XL Detect montage. If you look at the EMU 40 XL detect montage, this montage does not, you can see, contain anything relating to respiratory channels. Therefore, we need to tell the setting up here not to use that montage, but to use either a diagnostic sleep montage. Let's just check to see if the diagnostic sleep montage, because it does contain these channels that were used to record the respiratory channels, and it does have the proper channel types. And so I'm going to submit this one now for analysis. Click Submit. Alright, done. Click Review. Alright. So here, you can see that it has detected the event. Alright, and this was one of the questions that came through, that someone was using an EMU 40 head box, but it wouldn't matter if you were using any head box. The point is, you need to pay attention to which montage is being used to analyze the study. Alright, sometimes the default montage selected to analyze the study does not contain the channels that were used to record the study. Therefore, you need to go in here and change to a different montage. And we did that for the EMU 40. Someone was using X16, X15 to record a flow signal, and X5, X6 to record effort, X8, X7 to record effort. This is not part of the EMU 40 XL detect montage, so we created a separate montage. We called it diagnostic sleep. We went into analysis, we changed it to diagnostic sleep. Then we reran the analyzer, and it was now able to detect the events for this particular study. Okay. And I just got another question, so I'm going to take an opportunity to answer it. If you set analyzers on one acquisition computer, will the settings cross over to the other computers? Very good question. When you set your analyzer settings, they do not carry over to other machines. So there are settings like montages that do carry over, but unfortunately, when it comes to analyzer settings, they do not. So any changes any settings that you have in this window here, for example, the fact that you've picked the select montage for this particular computer, and the fact that these analyzers are displayed in this window, these settings, this whole page, will not carry over to the other computers. You have to go on each computer and make the change. All right, I have another question here. What are the rules to detect central apneas? But when it comes to central apnea, the analyzer will look at a flow type channel, such as thermistor, and it'll also look at any one effort type channel. So it's looking for two channels, one flow type and any one of the effort types. If the amplitude in both channels is reduced by, in this case, 80%, greater than 80%, then the amplifier is designed to classify that particular point as a central apnea. So it's looking at both the effort and also the flow type. Similarly, with obstructive apneas, it's looking for a reduction in the flow type, but it's not looking for a corresponding reduction in any one of the effort types. The analyzers do not detect mixed apneas, and so you won't see that. And so I hope that you found this useful. If anyone is interested in obtaining or wanting to listen to a copy of this recording today, please, and you don't want to wait for it to show up on the website, please email me directly. I'm going to put my email address. I will be happy to share the recording with you. So I thank you once again for taking the time today, and I look forward to speaking to you again on some future day. Thank you again, everyone, and this concludes our eseminar for